functions. So one to the back will be that. So syntax, as I said, we have two tickets. So the first kind of ticket is already open. It's adding a duration type. So it is what it sounds like. This type of duration of time. And mainly the reason we add that is because that allows us to have like literals that look nice. So you can have like 3H for 3 hours. And also the goal is really to make it easier to say, I want to query that for like 3 hours, so I can wear cheese for more than now minus 3 hours. So that does imply that we also do another ticket which has been open for a while, but we haven't tackled yet. It's operating support. So it's just nice syntax to do ads and everything. We have functions, so it's as it is. And there'll be function call, but we won't get that. So that's kind of ongoing. It's actually made reasonably quickly, but you know, it's just syntax, but it's not syntax.
Do you not cover in that also the sort of time-based functions?
I don't have time to answer the question right now. I'm not plenty of time for that. You see what I call it. Sorry. Yeah. So the second part, as I say, is like what we said about what we do about aggregation. So we already support aggregation. I want to kind of take a small example here. It's overly simplified, just to illustrate a couple of the next slide. It's just suppose, for example, you want to record the metrics of the loads of CPUs in a cluster. So you identify a CPU. For example, here I have like a machine name and number of machines. It's a simplified example. I have a measurement time for the load, and I store the load. Pretty straightforward thing. And today we can't do it because I said the average load for a given CPU. So you can do that, and it's great, but it just gives you the average load for the whole CPU over time. And you know, when you have aggregation, the one thing that comes up very quickly, group by, we don't have group by. So the first thing we're going to do is add a group by. So we have a ticket for that, which is 10.707. It's actually it has a batch available. It's been reviewed first time. I actually need to finish the review. So hopefully that should make it like 3.8. And so we'll support group by. So you'll be able to do send query, but you can group by at time. The only one thing I want to mention at the ticket is that, you know, it's a group by you all expect, with the caveat that as often we consider, we're not trying to like support any type of group by, we just support the one we can do efficiently, which means basically we aggregates, we group by following the clustering order problem. Which, by the way, in this example is that word is a little bit stupid because the time here is changed all the time, so you're actually not grouping anything. So that word is stupid, but still, group by is useful in other cases. But in that case specifically, if with that table I wanted to say group by the hour, for example, I want to have some kind of log of the average load every hour, that we're missing something. So that's the next piece that we'll add, and we also have a ticket for that already, and that's supporting functions in group by. So we'll support function like kind of globally, but amongst the function we'll add is probably a kind of floor function that just takes time and just a duration and like floor into the time. So here that means like I want to group by hours, my time by hour, just work by minutes. And so what I can say on the tickets is that we'll support, I say we support function generally, but we still need to only support function that allows us to compute stuff. Very right? And so we'll have a couple of restrictions that are here. They're on the tickets, so I'm going to. But basically, the function needs to make sure that stuff are still in clustering order, and so we can do the graph, the group as we get the data easily. So, so when we have that, we have a fairly generic support for group by and for doing core time aggregation. And as I said, a couple of those tickets are already done, some are in the work, and so they should come fairly easily. Now, I want to talk about the rest of the presentation is talking about an idea that is a little bit less well-defined, I guess, and I'll talk about two possible approaches for that. And I don't have so much time that I go into too many details, so I'll be a little bit wavy, but we have tomorrow and today to talk about the details, and I can share the details after that. But the basic idea is that, so all of that is about doing aggregation per time. But there is cases where you know that you would query your aggregates multiple times, and it makes no sense to repeat it every time. So very typical example is you have metrics and you run roll-ups. So you run roll-ups on the hour, on the day, maybe on the month, and you have dashboard that query those to show. And you don't want to recompute everything every time. That doesn't make sense. So you want to kind of keep your aggregates. So before going into all we can make that happen, I want to mention that probably the syntax that we see would make the most sense for that. Is basically to say we just have naturalized view, but we'll you can kind of select to do aggregation inside. So that's basically what we want. You want view that's pre-compute your aggregates, and you can query that, and you get your aggregates, right? So I call it aggregate view. We may or may not do that. We call it naturalized view, but I will see the implementation would be specific enough that it's not really exactly the same piece than naturalized view, but in principle it's the same idea. So it's that same idea. So a couple of points. If we want to do that and provide that, there's very minimal kind of guarantees that I think we need to provide, which is the view should be eventually consistent with the base table. That's kind of the this is working or not guarantee, right? We may want more guarantees, but it's a very minimal one. There was a kind of assumption that I've made, and I've think about those with a few of the people. The assumption that we kind of try to make is people use time series in Synchronous because Synchronous is good at writing fast and is as good at ingest write, and in time series you have fairly high ingest rates. And so if we come up with a solution where as soon as you create the view on the table, then your kind of write performances like go to shit, nobody will use it. So we do, I mean, I'm a little bit like foggy on as little as possible is absolutely not well defined, but I think the idea is we can't do too much work at right time, or that's just doesn't make sense. And that means that we've kind of tried a synchronous approach, and we come to the conclusion that that's probably not going to fly. What I mean by a synchronous approach, I mean you write to your base table and we maintain your aggregate live. So you write to the base table, and we also kind of update right away the aggregates kind of on the fly. So basically what I'm saying is doing counters for doing the aggregate, not going to work. So you would say, yeah, but you have counters. True, but how to just have to say that politely. They have downsides, among which they can overcount, for example. And that's the kind of stuff that we break in the very first thing here. So that doesn't work. Besides, they have very different write paths, and it's pretty important that we use that write path, and that kind of pretty much like break that certain thing. So it's not going to work. And we've tried to think about other ways to do it that is not as counter, but still trying to be synchronous. And maybe one of you would have a super smart idea, and we need to evaluate it more, but we actually think probably not going to work. So what that means is that the two kind of approach I talked about are all based on being asynchronous. So you kind of insert and you have a group by given time. So for example, you will group by the hour of your time, and the idea will wait, and after the hour is passed, we can compute stuff when we have everything, and then we do that asynchronously. And kind of the last point is we are kind of okay. So aggregating is not necessarily linked to time series. So in theory, we could have that kind of aggregation work for any type of data, but we think aggregate come up more often for time series. And I guess if we're happy to optimize for like time series type workloads. So what I mean by that is with time series, they're usually mostly immutable. So I say mostly. You insert and you really update the stuff you've actually inserted. That can happen, it's very rare, and it's roughly plus run order. Roughly, messages, we're distributed system, messages coming in different, like not necessarily in the order they've been meant by the user, but still, the distribution of the insert on the clustering order is not totally random at all. That's all I'm saying. All right, so let's talk about the approach we think about. And as I said, there are actually 3 options. There's 2 options that I've just discussed, but I just want to mention right away that the 3rd option is we don't do it. I mean, the 2 options I present, they're not necessarily perfect, and maybe the use case I described isn't worse the complexity, and so that option is always on the table. So I don't want to. I don't want anyone to come out of this thinking we'll do that no matter the price, right? You see there's some drawbacks, and so that's going to be big. But anyway, I'll focus on those 2 options that I call coordinator-based approach and relocate-based approach. The name are probably pretty terrible, but I'll come on that for the discussion here. Also, word of warning, I actually spend more time thinking about the relocate-based approach than the coordinator-based one, so I'll be a little bit more weighted in the coordinator-based one, so know that now well. And also, as I said, I want to contribute to all the details, so it may sound like I'm kind of sketching it, but. So anyway, the idea of the coordinator-based approach, for those that know InfluxDB, and the continuous query, that's trying to do roughly the same thing. So it's pretty basic ideas to say your aggregate for the hour. So every hour you run a job that say, what are been my updates for the last hour, and you compute the aggregate for those and you write them to the view. And I'll come back to what happens if something comes afterwards. But if you have your kind of time series assumptions that's tough coming roughly in order, that's kind of working.
So you said this is a coordinator-based approach, but it says we're going to scan out the replica?
Yes.
Okay.
That's why I said the name are probably terrible. So that's the second part that gives the name to the coordinator base. But so as I said, there's kind of 2 parts to that. The first one is every X time you have to find out what update you've made and for which aggregate you basically need to compute. And the second part is you need to compute. So the first part probably is to be done on replica because tracking update on the coordinator actually probably doesn't make sense. I'll come back to the scan part in the next slide. But the second part, and that's why I call it coordinator approach, is that when you compute, what we'll do is we find out which aggregate we want to compute. We actually read it with a given consistency level. That's probably configurable in the view. And you compute the aggregate, and you write the result to the view table. So here you kind of act like coordinator, hence the name, hence it's terrible. By doing a distributed read and distributed write. So I'll have a couple more detail on this on different part. The scan part, I say scanning, and I kind of potentially mean it. Scanning what has been the update since the last scan is a bit brute force. But in practice, we have minimax accessible metadata, and especially if you assume that we're using TWLCS or TTCS, so spaces table aren't mixed together too much, you can actually make that kind of scan not really reading too much that it shouldn't be. So it could be decently efficient. But we can alternatively try to track the update explicitly since our last scan by every time you insert something in this table, you can put something in the system table, and then the scan just look at the system table and it basically gets the job of what it should compute. Thing is, that's probably a lot more complex, particularly because we'll rely on that kind of tracking being fault tolerant. So the good thing about doing the brute force approach that as long as you remember when was your last scan, it's pretty easy to remember that in a four-point way. You just use the brute force the stuff, and you don't really have to care. So in that option, I think my scanning might be actually a third option. So when you find out what you need to compute, you will compute them. So distributed read, distributed write. But one problem we have, if we do that blindly, as I said, the scan is on replica, but that means every replica will replicate the aggregates. So we'll duplicate work by the number of replica. So if we want to avoid duplicating work, I say if we want, because that's maybe reinforcing it is also an option. But if you want to avoid the duplicate work, we have to have some kind of synchronization. So we have, so the different way to do that, either they want to compute and they actually generally synchronize, they like use paxels to figure out which we should be computing that, or we say, a replica actually only track stuff for its primary replica. But in all cases, that's probably a little bit complicated due to fault tolerance and stuff like that. If, for example, the replica only tracks the stuff for its primary range, what is the node die in fire? If you coordinate and you've been elected to compute and you fail, synchronization, distributed synchronization is hard, if that's what I'm saying. Okay, but anyway, one of the kind of reasons we consider that approach, one of the strengths of that approach, is that if I'm doing my writes at quorum on the base table and I'm doing my reads for computing my aggregates at quorum also, then we get the nice property that what we write is consistent with what is in the base table. At least it account only for stuff that has been inserted, but there could be late updates. But at least for what's in the database, you get a consistent count for those. So that's a nice property. The flip side of that is that I'm not entirely sure what guarantee we have as soon as you don't have this quorum thing. So if, for example, you write IRCL 1 on the base table, that means when you compute the aggregate, you could get something updated. And so when do you fix that? And so we need some other, some additional mechanism to fix that. Maybe you retry recomputing stuff later, but when later is enough to make sure it works. I'm not sure. I'm also not sure, so I think it's where I'm not even waiting here. And I think it's a bit of a problem, but probably fixable, but still, probably has to be fixable. And of course, we need to handle the update that come late. So the principle here is that after an hour, I know that everything I'm going to aggregate is supposed to be here, and of course, we'll take some kind of delta to take for slightly delayed insert. But at some point, you compute, assuming that you have everything for your window. But it can happen that you get a very late update, and so that's screwing up. And so we need to account for that. And that's probably not terribly hard because when we can check for every new insert compared to the last time we scan, and we can know if it's potentially involving something, and we can say if it does, it's late. Then we will compute. We just schedule a computation. We still have to care that for coordinates and stuff, so it's not trivial, but we can tell it. All right, so that's kind of the first approach, and I do want to talk about the second possible approach that we've considered, which is called Relocate. And I call it Relocate because that second approach is saying we're trying to make it a local problem. Basically, every replica will compute the aggregate for its own local data. So we don't have distributed read and writes for computed aggregate. We do it locally, much like a secondary index. That's basically saying it's an index of aggregate, kind of, for that way. So the first thing, just saying that imply that the aggregates live in the same node that base data. So that means that the partition key of the view is the same than the base table. So that's a limitation that if we want to use that approach, we have to impose. And the limitations are awesome, but at the same time, I want to contrast that with the fact that first, I think there's many examples where that's actually not a problem. For example, in my case, if I want to have roll-ups on the hour, the month, or anything, I will have the same partition key anyway. That's what I want, so it's not a problem. And when you don't want that, you can compose with MV. So you can say, I have a base table, I actually want to compute aggregates, but with different partition key. I can create a materialized view that has that different partition key, and I can create an aggregate view of that materialized view. So not awesome, but at least there's a workaround. So maybe it's not such a bad. Now, how does it work? And again, I have to go a bit quickly over that, but the idea is that the aggregates value that we have in the view will also have some kind of state. So in that solution, we'll kind of track the state of an aggregate. So the state would be those. So typically, new would be there is an aggregate that should be computed, but it's not been computed yet. So at least we track that it should exist. There has been some base table update for that window, but we haven't computed it. Invalidated would mean like we have computed that aggregate, but there has been some late update that has come since then. So the value isn't, it needs to be recomputed. And of course, we have computed that like, we have the value and we can send it back, and the being computed is equal to the sequence. So the idea on the base table right, we get a base table, we check which aggregates it's supposed to change, and we'll just insert in the view the kind of we push an insert with the new state. So we don't have a value, we just say there's an update for that aggregate. So internally, as long as we only get stuff, we have the new state internally, and then the third thing is that we do pretty much what we do on the first approach, which is every hour, every X time, we want to compute those aggregates now. So we'll find which aggregate has to be computed, and we compute it, and then we insert the value into the computed state. How do we find which aggregates to compute? Well, we have the same option as the previous one. We can brute force it, or we can track the thing. Tracking the update is probably much easier in that case because we don't really have to care about failure tolerance. And I'll come back to that in a minute. But the last part is like when we've computed that, if we get new updates that basically validate the value we've computed, then so there is no read before write. To be clear, we just do that. We just push a new state. But internally, the resolution will do when we resolve the cells, which has a new state and a computed state, we'll say, oops, it will become an invalidated state. So when we read and you see it's invalidated, I need to compute it. Now, the good part about having those state being tracked is that when you read, if you feel that, if you find that something is invalidated, you can actually fall back to computing it on read. So at least for the user, it sounds like you get the value. Yeah, slight bit on the latency, but you get the value. And that's why I said like fault tolerance, basically it's that part that makes fault tolerance less of a problem. Because if you try to compute and forgot, you're not failed in the middle of computation, and so you haven't tried. If on restart you don't recompute the value, you can still kind of rely on that for that computing on read. So you always have that fallback of computing on read, which is interesting. The other reason it's interesting, in my opinion, is that as I said, like I'm talking about time series data. And in that case, it's only the phase number 3 that is time series related. We assume that the data is time series. But you could imagine if you're fine computing on read, you could do that for data that is not time series related. You just won't do the phase 3 and you get computed on read. You still have some kind of cache that the first time you compute it and then it's there. So the next time you read, you get that. So it's a nice property that so that you use that even in the case where it's not time series. In the first approach, you really completely assume there is time series, so you wouldn't allow creating an aggregate beyond anything that doesn't have a time series kind of time. But the probably kind of drawback of this approach is that, so you do that locally. When you read and you're the coordinator, when you read at the consistency level that is greater than 1, you get multiple value from multiple replicas, and if they don't agree, you don't have a good way to kind of reconcile them. Not without reading the base table, I mean. We get different values, you don't know who is right, you don't know if you're supposed to mix those in a way. You don't really have a way, I mean, it's the same, It's the reason counters are complex, is that you have to know how to reconcile them. And you can't really do counter stuff because we need a special pass and whatnot. So I talked about. So anyway, that's the problem. That means that clearly, if we've gone that way, we'll probably start by limiting stuff to CL1. No, I happen to think that probably not as bad as it sounds. in the sense that we're talking about having aggregate be computed lazily anyway. So what that means is that you won't have, whether in that solution or in the previous one, you won't have the property that if you write your base table at quorum and then you read your aggregates at quorum, then you may not get the value because it's asynchronous anyway. So you don't have this write-read kind of consistency guarantees in the first place. So probably reading at CL1 is, kind of fine. It's less, it's not perfect, but I think in many cases, if you're accepting that it's asynchronous in the first place, you probably are okay with be limited to CL1. But by the way, when I say initially, I mean that I don't mean that we would let that as CL1. We can probably support the IRCL, probably slightly more slowly, but there is option and two possible options. The first one would be like detecting when there is a conflict, which is an entirely trivial actually. But we could add something to detect conflict, and then we could fall back to some kind of slow pass where you do read the base table when it happens, and you end up computing. So if your data is consistent most of the time, then it's probably fine. Sometimes you have a slow pass, but it's probably fine. The other would be to build on the 7168 tickets. Actually, probably the preferred solution, which is the repair word consistency level. And so it's that idea to track on which part of the data we know that are consistent and which part we know they aren't, and use that when you use more than CL1 query for the repair data you only query locally, and for the rest you distribute read. In that case, we would basically say for anything that is repaired, we just use the view, and for anything that isn't repaired, we do a base table read. And we do that perform or reconciling. But of course, that's not implemented, and that typically relies on the fact that repair is kind of reliable. So a little bit of work to really kind of make that work. But I do think we can make it work, just that's probably a little more involved. So anyway, that's the two ideas, and I'm going to be a little bit quick, but I kind of try to list the pros and cons of that approach, and I may have forget some, or maybe that my own opinion are transparent in that. But first, I think that the coordinate-based approach has the advantage is that the quorum thing works well. So if you do things at quorum, you get you get consistent stuff, and that's nice. The other one, which is probably not a terribly huge thing, but in that solution, the aggregate table is actually a normally replicated table. So we have a little bit more flexibility. You can repair the table itself. So that could be useful. Kind of trying to find advantages. But one of the downside of the approach that at first, or at least the thing on which I'm not clear on, is that consistency when you have not quorum stuff needs to other mechanism. It will make stuff harder. So there may be a solution, but that will make the solution more complex. The second one is that if you don't want to duplicate works to do Relocate, we need to synchronize, and that's also a little bit scary. And the kind of last part is what I said earlier, is that it's really just strictly limited to time series, based on the idea you have time series, because you compute stuff regularly based on the windows you're aggregating, so it has to be time-based. The Relocate-based solution has the advantages of that you deal with local stuff, so the computation are a little bit cheaper because you only read locally. So that may mean that doing more computations is less of a big deal. I don't know, at least that sounds a good thing to that. The second one is that I think the tracking of the state actually gives us more flexibility. In particular, that means we can actually, so in the previous state, we're computing every hour the stuff, but if our computation get late, because I don't know, maybe we have too many, maybe the load is so big that we're not able to compute everything in an hour, so stuff get delayed and computation get delayed, you only get a value when it's being computed, and you don't really know what happened. I mean, we can expose metrics, I suppose, and stuff like that, but you still don't really have guarantee. In that certain case, you're not that dependent on when it's computed, because you have the state and you can default to compute and read. So you can say, it's my stuff hasn't been computed, so I'll just compute it and read. And hopefully that doesn't happen a lot, but when that happens, at least I get a value back. So I think it's a nice thing. But the downside is that, as I said, getting CL1 on reads is more involved, probably. And the third one is we also have to deal with repair, for example, on the base table. When you repair the base table, we'd have to update the view, similarly to what we do for Synchronous and for materialized view, but we'd have to do the same thing here. And that does mean it will trigger a number of computation. And because repair tends to repair stuff it shouldn't do, we'll do more computation that we really should be doing. So there will be a bit of performance impact on that front. But the first solution, I don't know if it's really impacted by that. I suppose that depends a little bit what we do here. For the quorum case, we don't depend on repair because by using quorum for reading and writing, we're basically ensuring stuff are consistent. So we don't care about the base table being repaired because we've guaranteed we've got something consistent up on the read side. When we add this, we probably need to do something when we repair the base table and that unload it for him. So anyway, there's the two options. I want to mention one last point that I put aside because it's actually in fact both solution. Is that one thing we think we need if we do that is a way to expire. So we support TTL. So the most one way to support TTL is to say whenever my base table expired, my view expired. That's pretty easy to do. But one thing we really think people want is expiring the base table but not the view. And the typical example is I have metrics, I want to have rollups, and my base table, over time, I care about the rollups are IO granularity and not very specific data. So I get multiple rollups, and the more precise they are, the more quickly I want them to expire that. So we need to support that, and support that at a little bit of difficulty in the sense that because all those solutions rely on aggregate being computed on kind of the schedule, stuff can get delayed because they failure, because whatever. But when you expire the base table, you better ensure that the data that is dependent on that is computed. So you need to have a kind of dependency. And if anything, I see the replicability solution has the advantage is that because everything is local, when something expires, we could check that we've computed stuff. So we could do something about it. On the coordinate base, that's a little bit less good. But anyway, it's a problem that it's an additional problem. And that's why I don't know what to do.
All right. All right, so we should have snacks outside here.